Hello children, I am Shubhashish. Children, today we will learn how to draw triangles using different methods. Triangles are all around us, like in rooftops, road signs, and even in your favorite games. Geometry helps us understand how shapes are made, and today we will focus on right-angled triangles. We'll learn how to construct a triangle when we know the hypotenuse, the longest side, and one other side. In this lesson, we'll also explore why two sides and a non-included angle, side-side angle, may not always form a triangle. You will see that sometimes two triangles can be made with the same sides and angle. This will help you understand why some geometric rules work and others don't. Let's dive in and see how geometry can be used in real-life situations like building, designing, and more. Learning outcomes. After the completion of this lesson, you will be able to know: construct triangles using given sides and angles, such as the right hypotenuse side and side-side angle criteria. Learn how to construct a right-angled triangle with a hypotenuse and one side. Understand why the side-side angle rule does not always create a unique triangle. Keywords from this lesson are triangle construction, right hypotenuse side criterion, side-side angle criterion, congruent triangles, right-angled triangle, hypotenuse, and non-included angle. Children, let us learn construction of a triangle if the length of the hypotenuse and one side is given. Right hypotenuse side criterion. Example 1. Draw a triangle PQR which is right angled at P, with QR is equal to 7 cm and PQ is equal to 4.5 cm. Solution. Step 1. Draw a rough sketch of the triangle according to the given information. Step 2. Using a ruler, draw a line segment PQ is equal to 4.5 cm. Step 3. By using compass at P, draw 90 degrees so PS perpendicular to PQ. This shows that R must be somewhere on this perpendicular. Step 4. Take Q as a center and using compass and ruler, draw an arc of 7 cm, which intersects PS at R. Step 5. Now join QR by using ruler. Now we get PQR is the required triangle. Example 2. Construct triangle LMN where angle M is equal to 90 degrees, MN is equal to 8 cm and LN is equal to 10 cm. Step 1. Draw a rough sketch of the triangle according to the given information. Step 2. Using a ruler, draw a line segment MN is equal to 8 cm. Step 3. By using compass and ruler, take 90 degrees at M and draw MX perpendicular to MN. Step 4. With N as center, using compass and ruler, draw an arc of radius 10 cm to cut MX at L. Step 5. By using ruler, join LN. Now we get LMN is the required triangle. Children, now let us learn construction of a triangle if two sides and non-included side are given. Side-side angle criterion. Side-side angle congruence rule. The side-side angle congruence rule states that if two sides and an angle not included between them are respectively equal to two sides and an angle of the other, then the two triangles are equal. However, with this congruence rule, two triangles are not said to be congruent since the sides of the two triangles may not be on the same corresponding sides. Both the triangles might end up having different shapes and sizes from each other. Thus, the side-side angle congruence rule is not valid. Proof of side-side angle congruence rule. As we already learned that this congruence rule is not valid and triangles cannot be congruent. Let us see the reasons as to why side-side angle will not work. Consider the following figure. In the two triangles, triangle ABC and triangle DEF, we have AB equals to DE, BC equals to EF, and angle C is equal to angle F, non-included angles. We see that even though two pairs of sides and a pair of angles are correspondingly equal, the two triangles are not congruent. The two triangles do not have the same shape and size. Therefore, the side-side angle congruence rule is not valid. Let us consider an example to understand this better. Example: construct a triangle ABC such that AB is equal to 5 cm, AC equals to 4 cm, and angle B is equal to 40 degrees. Solution: Step 1. Draw a rough sketch of the triangle according to the given information. Step 2. Using a ruler, draw a line segment AB of length 5 cm. Step 3. Using protractor and ruler, draw a ray BX making an angle 40 degrees at B. Step 4. With A as center and radius 4 cm, using compass, draw an arc to cut ray BX. Step 5. Mark the intersecting point as C and using the ruler, join CA. Now we get ABC is a required triangle. Step 6. But can you cut the ray BX at any other point? Yes, here angle B is acute angle. Using the compass with 4 cm at A, draw the arc, cuts the ray BX again at C'. Let the intersecting points be named as C and C'. Step 7. Now join A and C' by using ruler. If we join C and A, we get one triangle, and if we join C' and A, then we get other triangle. So we may have two triangles for this example. These are the two triangles. Thus, two different triangles have been successfully constructed. That is, triangle ABC and triangle ABC' with a pair of sides and a non-included angle. This means two things. A pair of sides and a non-included angle will not uniquely determine a triangle. In other words, congruence through side-side angle is invalid. A pair of sides and the included angle will uniquely determine a triangle. In other words, congruence through side angle side is valid. Therefore, it is proved that the side-side angle congruence rule is not valid. Points to remember. In right hypotenuse side criterion, a triangle is formed using the hypotenuse and one side of a right angle triangle. The side-side angle criterion may create two different triangles, as two sides and a non-included angle don't always make a unique triangle. The side-side angle rule doesn't work because two triangles with the same sides and angles can have different shapes. Thanks for watching.